Greetings for the day. I am Manya Dhawan from school registration number 56, and I will be talking about the Fibonacci sequence, or more commonly known as the golden ratio. I will be talking about its origin, the concept behind it, its examples in everyday life, how we can prove it, how we can make it using GeoGebra, and its appearance in famous artworks. So, let's talk about the origin of the golden ratio. A 13th century Italian mathematician Leonardo Pisano, also known as Fibonacci, in a sense, the son of Bonacci, had pondered the question: how many pairs of rabbits can be produced from a pair of rabbits in 1 year if there were optimal conditions? Well, female rabbits always give birth to pairs, with each pair consisting of a male and a female, while they can't reproduce until they are at least 1 month old. So for the first month, there is only one pair. In the second month, when the female gives birth, we have two pairs of rabbits in all. And similarly, during the third month, the original pair of rabbits produce another pair of newborns while the first offspring grows into adulthood. This gives us three pairs of rabbits, in which two will give birth to two more pairs in the fourth month. Fibonacci eventually concluded that in a year, 223 pairs of rabbits would be born. The order goes as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, so on to infinity. Each number is the sum of the previous two in the series, like 1 plus 2 gives us 3 and 2 plus 3 gives us 5. This series is known as the Fibonacci numbers or the Fibonacci sequence. And the ratio between any two consecutive numbers is 1 is to 1.618034 and is called the golden ratio. While 1.618034, which is irrational, is known as the golden number. Now, let's talk about the concept behind the golden ratio. The golden ratio can be used to describe the proportions of everything, from nature's smallest building blocks such as atoms to the most advanced patterns in the universe like celestial bodies. Nature relies on this proportion to maintain balance and so do financial markets. The Fibonacci sequence goes on to infinity and provides us with the means to understand the golden ratio, which is represented as pi, that is a Greek letter, or 1.618034, that is an irrational number. When any Fibonacci number is divided by the previous number, the resulting number is approximately equal to 5. And the further we go in the series, the more closer the values get. Phi is calculated using 1 plus under root of 5 by 2. As we can see, the rule continues up till infinity, with 0 plus 1, which is equal to 1, 1 plus 1, 2, 1 plus 2, 3, and so on. Now, let's talk about the Fibonacci spiral in everyday life. The Fibonacci spiral can be witnessed in day-to-day life as well, like in storms and hurricanes, on the human face from our ears to the nose to our mouth, and as a matter of fact, we can see many Fibonacci relationships on our whole body. Shells are the most beautiful representation of the Fibonacci spiral. Now let's prove the golden ratio. For any beehive, if we divide the female bees by the male bees, we'll get 1 is to 1.618, which is the golden ratio. Sunflowers have opposing spirals of seeds that have a 1.618 ratio between the diameters of each rotation, giving us the golden number once again. The human body. If we measure from our shoulder to our fingertips and then divide this number by the length from our elbow to our fingertips, we will once again get 1.618. So don't all these things prove the golden ratio? Now, let's make the Fibonacci spiral using GeoGebra. As we know that the Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13 on to infinity. We'll be making squares of these dimensions in descending order, starting with the square of side 13 units, then 8 square units, 5 square units, 3 square units, 2 square units, and 1 square unit. We will now take a circumcircular arc and place it on the points B and D by taking point C as our center. Then an arc from D to K, taking E as our center. And we'll be continuing like this till we make arcs in all the squares. The spiral that we see inside these 7 squares is now the Fibonacci spiral. We will now be measuring the dimensions of all the squares to confirm their lengths, with the biggest one being 13 square units, the second one 8 square units, then 5, 3, 2 square units, and the smallest one being 1 square unit. This is how we can make the Fibonacci spiral easily using a simple app known as GeoGebra. The Fibonacci spiral can even be seen in many famous artworks, like Da Vinci's legendary Mona Lisa, The Girl with the Pearl Earring by Vermeer, Dali's Sacrament of the Last Supper, and The Great Wave by Hokusai, to name a few. Isn't the golden ratio just unavoidable? Thank you. I hope you enjoyed my presentation and got to learn something new.